We're on problem 36, and it says, what is the area in square units of the trapezoid shown below? So when you just look at this, you're like, okay, trapezoid, do I know the formula for the area of a trapezoid? And you might get confused and all of that. But you say, well, trapezoid, I can break it up into a rectangle and a triangle. If I were to draw a line right here, if I draw a line right there, then I've broken up the trapezoid into a rectangle and a triangle. And then if I know the dimensions of each of those, I know the dimensions, I know the area of each of them, and then I know the area of the entire thing. So let's see. What's this height right here? Or this width, I should say. Well, we're going from 0 to what? X is equal to 8 here. Right? I just went straight down from x is equal to 8, y is equal to 5. So this dimension is 8. And then when we go from x is equal to 8 to x is equal to 12, how far is that? Well, that's going to be 4. Right? So this is 4, and this is 8. Fair enough. And then how high is this rectangle? We're going from y is equal to 0 to y is equal to 5, so that's 5. And of course, this is 5 as well. So we're done. We're ready to figure out the area. The area of the rectangle part is 8 times 5, that's 40. The area of this triangle is 5 times 4 times 1/2, right? If we didn't put that 1/2, we'd be figuring out the area of this rectangle right there. So it's 5 times 4 is 20 times 1/2 is 10. So the area of both of these combined is 10 plus 40, it's 50. 37. The figure below is a square with 4 congruent parallelograms inside. This looks interesting. What is the area in square units of the shaded portion? So the shaded portion is the whole square minus the area of the parallelogram. So the whole square, that's easy. It's 12, and the height is 12, but since we know it's a square, we know the width also has to be 12. Right? So the area of the whole square is 144. And now we have to figure out the area. If we know the area of one of the parallelograms, we know the area of all of the parallelograms because they are congruent. So let's see if we can figure out the area of one of the parallelograms. So there is actually a formula for the area of a parallelogram. It's actually just the base times the height. And they actually give us that, but let me show you that they give us that because it might not be obvious to you. So let me try to draw it. So I want to use my line tool. Nope, that's not the line tool. So one side, it goes straight like that, and I come down like that. Good enough? Okay, now if I look at just this parallelogram, they tell us that the height here is 3, right? This height is 3. And I know it's the height because they told me this is a 90-degree angle. And they tell us that the base is 5. And I'm telling you that the area of a parallelogram is just the base times the height is equal to 15. But you shouldn't just take my word for it. That should make intuitive sense to you. And the way to think about it intuitively is imagine if we were to take this part of the parallelogram, if we were to just cut it right here, and if we were to move it over here, if we were to cut that off and move it over here, then the parallelogram would look something like this. You'd have the part that we didn't cut off, right? And then you move the cutoff part over here. And now the dimensions, this base would be 5, and then this height would be 3. And the area of this rectangle is 15. And there's no reason why the area of this should be any different than that. We just rearranged its parts. So that's why the area of a parallelogram is just the base times the height. So the area of each of these parallelograms are 15. So the area of all of them combined is 15 times 4, which is 60. So 144 minus 60 is what? 84. 84, and that's choice B. Problem 38. What is the area in square meters of the trapezoid shown below? So to figure out the area, we could break it up into these rectangles and triangles. To figure out the area of this rectangle, we need to know its height. We need to know this height. And actually, we'll need that to figure out the area of the triangles as well. So what's this height right there? So let's see. We know that this distance is going to be 6. It's a rectangle. That distance is going to be 6. If that distance is 6 and both of these are 5, both of these triangles here are going to be congruent, right? Because this length is equal to this length. This length is equal to this length. And we could also make, this angle is equal to that angle. But anyway, so let me do it in another color. what's the length of these two green sides? Let's call it x, right? Well, we know that when you add x plus 6 plus x, it has to equal 12, that whole top part. So you get x plus x is 2x plus 6 is equal to 12. 2x is equal to 6, x is equal to 3. And you might have been able to solve that in your head, that if that's 6 and these are the same, that both of these are going to be 3. And now we can use that information to figure out this height right there, right? Because if we just draw this triangle right there, that's 3, that's 5. This is some unknown side, A. And you might already recognize, we're going to use the Pythagorean theorem, and this is a very typical type of right triangle. So you might already be able to guess what A is, but we'll solve for it. So we can know that A squared plus 3 squared is equal to the hypotenuse squared, the side opposite the 90-degree angle squared. So that is equal to 25. 5 squared is 25. A squared plus 9 is equal to 25. A squared is equal to 16. A is equal to 4. A is equal to 4, and now we're ready to figure out the area. What's the area of the rectangle? 6 times 4, it's 24. What's the area of each of these triangles? 3 times 4 times 1/2. 3 times 4 is 12, times 1/2 is 6. So the area of that triangle is 6, the area of this triangle is 6. So 6 plus 24 plus 6 is 36. B. Problem 39. What is the area in square inches of the triangle below? Interesting. Okay, so this is a equilateral triangle. All the sides are equal. And so we could actually say that this, since these two triangles are symmetric, we could actually say that's equal to that. And this comes to a general formula for the area of an equilateral triangle. But let's just figure it all out. So this side's going to be 5, and this side's going to be 5. If this is 5 and that's 10, what is this side right here? Let's call it x. Pythagorean theorem. This is the hypotenuse, so x squared plus 5 squared plus 25 is going to be equal to the hypotenuse squared, which is equal to 100. X squared is equal to 100 minus 25, 75. X is equal to the square root of 75. 75 is 25 times 3, right? So that's equal to the square root of 25 times 3, which is equal to the square root of 25 times the square root of 3, which is equal to 5 roots of 3. So x is equal to 5 roots of 3. And now, what's the area of just this right triangle right here? This one on the right side. Well, its base is 5. Its height is 5 roots of 3. So it's going to be 1/2 times the base, 5, times its height, 5 roots of 3. And that's what? 1/2 times 5 times 5. So it's 25 root 3 over 2. And that's just this triangle right there. Well, this triangle is going to have the exact same area, right? They're congruent triangles. So the area of the figure is this times 2. So 2 times that is equal to just the 25 root 3. And that's choice B. Next problem, problem 40. The perimeter of two squares are in a ratio of 4 to 9. What is the ratio between the areas of the two squares? So let's draw two squares. So that's one square, and let me draw another square. That's another square. And let's say that the sides of this are x, right? And the sides of this one are y. So they're saying the perimeters of the two squares are in a ratio of 4 to 9. So the perimeter of the first square is 4x, right? X plus x plus x plus x. So the perimeter of the first square is 4x. The perimeter of the second square is 4y. So that's the ratio of the perimeter of the first square to the perimeter of the second square. And then that is equal to 4 to 9. That is equal to 4 to 9. And they say, what is the ratio between the areas of the two squares? So they want us to figure out the area of the first square is x squared, and the ratio, right, base times height, x times x, and the area of the second square is y times y. So they want us to figure out what that is equal to, right? Well, this is x squared over y squared. This is the same thing as x over y squared. So if we can figure out what x over y is equal to, we can just square it and we'll get x squared over y squared. So let's try to do that. So they give us this. Let's see. If we divide, well, this just simplifies, right? 4 over 4, no reason. X over y is equal to 4 over 9, right? X over 9 is equal to 4 over 9. So let's substitute that here. So x squared over y squared is equal to x over y squared, which is equal to 4/9 squared, which is equal to 16 over 81. Or the ratio of the areas of the two squares is 16 to 81. Choice D. Maybe we could fit one more problem in there. Actually, no, I'm over 10 minutes. I'll stop right there. See you in the next video.